Okay, today is September 17th, and we have a warm-up here on our rational number chapter. This is a mixture of grade 4, 5, 6, and I guess 9. I guess the last question is like a grade 9 question, so I don't think you've ever done it until now. So we'll look at the first question here, and it says 1.7 plus 3.9. When you were adding decimals, what you learned back in grade 4 was line up your decimals and add your place values. This is the algorithm for solving it. 7 plus 9 is 16. So you get 16 tenths, which is 6 tenths and 1. And add your ones together, 1, 2, and 3 is 5. So your answer is 5.6. If you had to do that without the algorithm, if you had to do it without lining up your decimals, what you could do is you could think about money. You could have thought of $1.70 plus $3.90. We add some insignificant zeros to make it now into money. And you probably could have mentally calculated that answer by thinking about money. Sometimes that works too. In the second question, what you learned in the second question is grade 8. What you learned in grade 8 was to estimate first, okay? So if I estimated, I'm going to make this 2 times 4. My estimation's 8. That's what you learned in grade, I think it was either 7 or 8. I can't remember. One of those 2 grades. Once you know that, you don't put your decimals down. You just put your numbers like that. And you multiply the 9 by each of the place values here. So 9 times 7 is 63. Carry your 6. 9 times 1 is 9 plus 6 is 15. Then you go to your next place value, put a 0 down for your placeholder. 3 times 7 is 21. 3 times 1 is 3 plus 2 is 5. Add them up. You get 663. Now you place your decimal according to what your estimation was. So since your estimation was 8, the place you can put your decimal that will closest approximate the number 8 is between the 2 6's, and therefore your answer is 6.63. Okay? How many forgot that? Probably a lot of you. Okay. We'll practice that. It's good that you have that algorithm in your head to how to multiply decimals without a calculator, even though your generation will always be within arm's reach of a calculator because you always have your phone on you. Back in my day, when I was a young student, we didn't have calculators all the time, so we had to know how to do it. So it's important that you do know it. The next one is estimate. So when you estimate, we do exactly what we did before. We say, what is 2 divided by 4? Now, if you have a hard time dividing like that, remember what we said. Division can also mean you can think of it as a fraction. And sometimes when we think of it as a fraction, we can do the division much easier. Because if we think about 2 over 4, what is that really? That's really a half, isn't it? Right? So therefore, your estimation will be a half. Does that make sense? I thought of it as this, which makes sense because I just rounded to the nearest whole number place value. I then thought of it in this structure, which we would call fraction divisional structure. And then I could do that mental math in my head. 2 divided by 4, or in lowest terms, 1 divided by 2 is a half. If I actually make a calculation and said, what is 1.7 divided by 3.9? My calculation is 0.44, right, roughly. But that's pretty close to 0.5. So my estimation was fairly accurate without having to do the actual division. In the real world, if this was a question, you would never solve it by paper pencil, ever. But it is important that you can estimate your answer and then use a calculation to see what the actual calculation is. The last question is tough, and I'll tell you why. I'm going to go back to our money idea. If you think about money, you have $1.70 and you have to take away $3.90. So what we really are saying in effect is you're going to have negative value. You're going to owe money at the end of it. If you have $1.70, you have to take away $3.90. So if I thought of it in terms of integers, and let's just put back my estimation again of this, 2 take away 4. If I did this question, you could keep flip change like this, couldn't you? 2 plus negative 4, that would be the same answer, and your estimation would be negative 2, agreed? So with that keep flip change, if you keep flip change this, keep flip change that to negative, and if you applied your thinking about how would you do integers when one's negative, one's positive, what do you have more of, positives or negatives? You have more negatives, actually, negative 390, right? So what we're going to do to solve it is figure out how many more positives do I have than negatives. So in effect, what I'm doing here to solve that subtraction is I'm reversing it, right? I'm going to subtract it like this. So 3.9 take away 1.7, I subtract that, becomes 2. Subtract that, becomes 2. Therefore, I have 2.2 more negatives than I do positives. So my answer for that question is 2.2. I'll guarantee you half of you did this. I'll guarantee you that half of you reversed, instead of putting the one you have more of up top and the one you have less of down below, you probably kept it in the order you saw it. And you went 7 take away 9, can't do it, so you borrowed. You went 9 take away 17 is 8. 0 take away 3 is negative 3. Some of you probably got negative 3.8, maybe. Did anyone? Just out of curiosity. Thank you. So that algorithm obviously doesn't work, because if we think about it, I had $1.70, I subtracted $3.90. I can't be $3.80 in the hole. It doesn't make sense, right? But it does make sense when I say, what do I have more of? And I subtract that from each other.